morning, ladies and gentlemen. My name is Burak Türker. I'm a civil engineer and working as a test engineer, also support engineer for Prota Software. Today, with my colleague Oğuz and I, will talk about performance-based design and assessment with Prota Structure. As an overview, first of all, I will talk about how to model existing building, including members, materials, reinforcement, steel conditions, etc. After that, I will perform preliminary design and show you how to arrange reinforcement steel and how to copy them to other members. Then we will have a quick look on assessment user interface and check the assessment report. After all, my colleague Oğuz will talk about Prota Structure OpenCS integration and nonlinear member and material definitions. So let's get started. Here is the model that I will use for today's webinar. Modeling structural members is same as new building modeling, so I will directly skip to material definitions. With Prota Structure, you can edit member materials individually, or you can set default materials for all members as well. To edit specific member material, simply go on the member, for example, this member, and open member properties and open section manager also. Here's the default materials are selected. I'm clicking on default. Here some of the concrete classes are listed on the left side. You can select one of these. Also, you can add new concrete class. All you need to do is just click on this plus sign, green plus sign. So you need to enter the parameters of this new concrete class. Let's pick C16. So after selecting the concrete class, materials for longitudinal bar and link will also be visible and selectable. So you can also change the material class for rebars. After all, you can also get back to default material selection. All you need to do is press on reset to default button. Okay. Before closing the member properties window, so you should click on update, otherwise all changes will gone, there will be no change. So you should, after all changes for geometric properties, also material, you need to press on update before closing the member properties dialog. Now I will show you the second method. It can be done from building an analysis form. You can set default materials from this dialog. Instead of changing materials for members one by one, you can change material class for all concrete columns or concrete walls, beams at the same time. Similar dialog will open here. There is also rebar diameters limitations. It's really useful for preliminary design. You can pick which diameters we'll use for design for all proto structure use. Now I want to talk about seismic parameters. So we are for nonlinear time history analysis. We are using response spectrum basic scaling on ground motions. So the seismic parameters, especially response spectrum, should be selected properly. Now I want to show you the preliminary design. First, we will need to perform a building analysis. After building analysis completed, I will show you the preliminary design, also how to model existing steel bars and how to copy them to other members. For preliminary design, I will simply open reinforcement concrete column wall design dialog. So I will design all of the members. After that, I will get into one of the members and design it for existing member and copy the existed reinforcements to other members. You can design all members with simply one click. Also, I will show you how to design them one by one. So preliminary design is completed. Now I want to show you the design for existing rebar information. All steel bars listed here with their diameters and quantities. So you can change them. For example, let's make it 0. Also, let's make it 1. Also, here this dialog for longitudinal bars, and you can also change the shear bars links. First of all, you need to select this edited box here, so you can decide on, you can set diameters for span, for support. Also spacings are here. Let's make it 10. After editing reinforcement bars for one member, you can copy bars, so all pastable or members which have same dimensions will be visible, will be shown by Prota Structure. So you can choose them, or you can say paste bars to all if all reinforcement details are same. And after selecting members, just press on paste bars. All reinforcement details are same now. For today, I will use approximate steel ratios for beams, but for example, I will show how to copy beams reinforcements also. So let's pick this one. So there is some default bars are selected. You can change the pattern. And for changing existing reinforcement details, you can click on the information and it will be changeable. So we can change the quantities, also we can change the diameters of bars. Also we can change the shear lengths, quantities, spacing, and we can update the equations here. So after arranging the bars, now we can copy it also. Again, similarly, Prota Structure will show you which ones can paste the reinforcement information. Now, after arranging the steel reinforcements, I want to give information about how to model existing buildings' reinforcement conditions. When you assess the building, what you usually do is you go to building site and take some measurements, you get information about corrosion levels, etc. So also you may have blueprints of building, but existing building conditions after the measurements, if the existing building conditions may not match these blueprints. So with Prota Structure, you can easily model these kind of information. For example, I will show you the corrosion factor. Let's pick that member. Right click on it. So you can change steel corrosion ratio. Also, you can change steel realization ratio. Here is some default parameters are listed. None, low 10%, 30% for medium, or and 50% for advanced corrosion on these members reinforcements. So let's pick 10. You can enter steel realization ratio. Uh, as I said, you may have the blueprints of the building, but existing measurements on existing building may not match these blueprints information. So again, just go on member and open steel realization ratio. You can decide on the factor. It will directly proportional to capacity of these members. So let's pick 90%. After decide on the value, you can apply to selected columns. You can make multiple selection. You can apply to all columns in current story, and you can apply to all columns in model. Before I go into building assessment interface, I will talk about some modeling limitations due to nonlinear analysis procedures. Firstly, you shouldn't use shell definitions for shear wall modeling uh, because finite element shell models are not available for practical nonlinear analysis. They may be used for academic research, academic purposes, but mid-peer model is more practical so far. So we are using mid-peer model for wall models. Secondly, in order to decrease the load of analysis, you should not include slabs into building model. However, you can use finite element load decomposition for more accurate slab load decompositions to beams. So you can use load decomposition by finite element feature. So let's have a quick overview on assessment user interface. Prota Structure supports various methods for assessment. One of them is displacement-based linear elastic method. Here is an you should pick linear elastic analysis. Displacement-based linear elastic method. The method depends on elastic core rotations. It's an approximate analysis and has very strict limitations. Also, it is not valid for every structure since it's an elastic method. It's out of scope today. Here is the conduct method validity controls. This selection is for displacement-based linear elastic method. So one of the other method is risk assessment method. Here you can see risk assessment method, and it's also out of scope today since it's an also linear method. However, it's an important method for fast determination of building at risk. So user can quickly have an idea of building performance level between life safety and collapse prevention. The other available methods are pushover analysis and time history analysis. My colleague Oğuz will give detailed information about these methods. Here is you can set building information level. According to measurements you perform or blueprints you have, you will decide on building information level. You can select limited or detailed information, or you can set an user-defined factor by picking other option. So limited factor is 0.875 and detailed factor is 1. Also you can pick other and enter user-defined factor. Building information level is directly proportional to member capacities. So under building information level, there are some earthquake levels and performance goals. For example, DD1, which is may also known as MCE, has 2,475 return period, or DD2, which is known as design earthquake, which is 475 return period. And you need to set performance goals according to earthquake levels. The performance goal selection may be made by due to some code requirements, also may be made by client expectations. At right side from here, you can enter approximate steel ratios. Since we performed preliminary design for walls and columns, we will not use approximate steel ratios, but I will use approximate steel ratio for beams. You can set top and bottom longitudinal steel bars separately. Also, you can enter link information and spacing, link diameter and spacing. Finally, I will talk about general options. Normally, earthquake load effects are included. I'm talking about first option. Normally, load effects are included into moment curvature analysis. However, if you want to take only gravity loads for maybe academic purpose, or you may want to see other options, you can pick this selection which uses only vertical loads for moment curvature analysis. Also, for second and third option, normally plastic moments are used for demand capacity ratio calculations. However, user to be on safe side or some other reasons, user may want to use yield capacity for member moment capacities. So you can determine which capacity will be used for demand capacity ratio calculations. It may be either plastic moment capacity or yield capacity. So these are the options for this. Also, as I said, conduct method validity controls is for linear elastic existing building assessment method. So it has strict limitations and not valid for every structure. So there is some code requirements to apply this method. and we can check them with selecting this conduct method validity controls. Finally, I want to show you some retrofitting techniques. Firstly, I will talk about column jacketing. So simply go on members and right click and select insert column jacket. Here you can set column jacket thickness. You may want to delete the original column. Maybe you don't want to get these existing column to get any load. Also, you can set these column jacket as non-moment transferring jacket. Here's the material information about jacket. So let's press OK. I set all stories as similar stories. Column jacket is modeled on every member. Second retrofitting method I want to talk about is retrofit walls. So open wall properties dialog and go to 3D tab. There is some wall models listed here. So if you will perform nonlinear analysis, you should use mid-tier retrofit wall model. You can model it as a normal wall. So after modeling these members, for design these members, these new retrofit members, you can go again reinforced concrete column wall design window. These members will be listed here, so you can see with X here, S14X, X14X for all stories. These are column jackets. Also, you can see new retrofit walls here, so you can perform similar designs as normal new building modeling. So my part ends here. Now my colleague Oğuz will continue the webinar. Thank you for your attention so far. So I will leave the webinar to my colleague.
Good morning, everyone. If there is any problem with my voice or the screen, please write us. My name is Oğuz. I'm a software developer at Prota Software. Myself is also a structural engineer. I share my screen now. I hope there is no problem. I really would like to extend my best wishes to you. Please follow the health authorities' guidance and stay home and stay safe. Today I'm going to talk about Prota Structure OpenSys integration, pushover analysis, nonlinear time story analysis, ground motion selection, ground motion scaling, and detailed reports. Firstly, I want to talk about OpenSys Prota Structure integration. OpenSys is an open system for earthquake engineering simulation, which is developed by PEER, Pacific Earthquake Engineering Research Center. OpenSys have been developed in so many years and used for many research purposes and real projects. Let me tell you about the interface a little bit, and then I will talk about the OpenSys again. Here, let's open existing building interface again. and let's get over it. The project Prota Structure is saving the project for applying the change on the model before you open the existing building assessment or building assessment interface. Project state. When you open the existing building assessment interface, here there are two nonlinear approaches are represented. Let's click on pushover analysis. If you click on pushover analysis or time history analysis, Prota Structure warns you about analysis model generation. The generated analysis model is used for preparing pushover force vectors or determining the period of the structure for scaling the ground motions. When you select pushover or time history analysis, here you can see model TCL export paths, model.out results paths, and OpenSees paths are also shown here. You have to select the path of the OpenSees executable file to use the this module. Prota Structure creates and generates all the nonlinear definitions, member definitions, and section definitions, and by using them, generates TCL files for OpenSees environment. First, just click here and select OpenSees .exe, and here green text is set. OpenSees executable file is found in the given directory. Let's talk about earthquake levels and performance goals. DD1, DD2, DD3, and DD4 are representing the return periods of the given earthquake. DD1 is 2,475 years return period earthquake. DD2 is 475, DD3 is 72, and DD4 is 43 years return period earthquakes. Represents these earthquakes. Here's predefined performance goals: limited damage, controlled damage, and collapse prevention. Limited damage is same as immediate occupancy, and controlled damage is life safety, and collapse prevention is also another performance goals. Let's talk about pushover parameters before I mention. Okay. Sorry, some of our users said the noise is a little bit interrupted. I will try to fix it. I hope it's okay now. For pushover interface, there is total number of steps: pushover direction, target displacement, and control node. You can see the analytical model of the your selected model is presented in here. It's presented here for selecting the control node. Let me tell you the logic behind the pushover analysis. I will just show on some multi-degree of system simplified structure. Let's say this is our very simplified. It's just for explaining the logic behind it. When you select the control node, let's select node 1 as our control node. Let's name them accordingly. Let's select control node 1. When we generate the analysis model for our structural model, we generate our pushover force vectors. Those force vectors are now only used as equivalent static pushover analysis. That means the force vector in here, the forces, reference forces that you push the structure, is created by equivalent linear static earthquake analysis. And by using those force vectors and pushover direction, you will decide which direction you will push the structure. And the target displacement is the key point where you push the structure by using those force vectors and controlling the selected node. And if we enter 20 centimeters target displacement for our diaphragm node, the structure will be pushed in that direction by using force vectors and by controlling this node. Let me just clear my drawings and let's make analysis for. Some of our users are asking if we do not give rebar definitions for any structural members, what will be happened? Prota Structure automatically warns you about members without any valid rebar data. And if you click OK, estimated rebar values, rebar ratios will be used for those elements. In order to express the nonlinear behavior on structural members, you have to enter your materials properties, rebar definitions, and section sizes correctly. Let me just prepare the force deformation and tell you how we prepare our nonlinear definitions. First of all, let's change pen color as. All right. First, for each members in our structural members in our structure, we prepare fiber models. This is an highly exaggerated drawing. Sorry for its quality, but I think it will show you the logic behind it. Let's just turn the mouse and put it here. And when we prepare our fiber models with all reinforcements fiber locations, we prepare our material models for each of these fibers. After preparing by using Mander material models, after preparation of those fiber section definitions, nonlinear section definitions, we prepare our force deformation. We export our force deformation relationships as moment curvature relationships. If I think there's some connection problems. If there's any problem, just write us. This is again highly exaggerated drawings. We prepare our force deformation relationships for both directions for members, and assign those nonlinear definitions to our members. You can see how those force deformation relationships are prepared for each end and for both directions, and how we idealize those moment curvature relationships by using bilinear curve from our interface. Plastic hinge definitions are assigned by using finite length hinge zone method to OpenSeas. For shear walls, we are also using 6 integration points, and we do not concentrate on one region. We just simply give a nonlinear definition to the whole member integration points. And after doing our analysis, you can nonlinear analysis, you can here check out the pushover curve, and you can here check our detailed results, how much plastic rotation is occurred for which members in which direction, which local direction. And for finite elements also you can see the results, and here's the node results for all nodes are displayed in here. Let's talk about detailed reports of the pushover analysis. When we prepare pushover analysis reports, there's here you can see member labels and plastic rotation values are here represented for both I and J ends of the structure. Let's talk about how we assess the structure. At this phase of the webinar, I will talk about more on our roadmap, what we are planning to do, and what new features will be prepared for this nonlinear analysis methods. Here's what I say before: inner force and deformation relationship, and immediate occupancy, life safety, and collapse prevention. We prepare those safety conditions, those limit plastic rotations, by using the formulations shown in above, and at our pushover analysis report, we are showing our pushover curve and member failure type definitions. You know, if member has a brittle behavior, it will work on force. The deformation is controlled by force, but we, as structural engineers, we didn't want that behavior. We prefer ductile behavior, and all ductility controls, ductility checks are presented here. And for member assessment results, all members failure types, storage shear ratios, and plastic rotation limits and plastic rotations will represent here. And let's talk more on time history analysis also. If you select time history analysis, there are 3 tabs are available for the user. For now, I will just use default ground motions. Those default ground motions are just entered as is for giving rough information. I know ground motion selection is very hard procedure. It's really, it has really strict limitations if you select your ground motions not correctly. Sorry. The behavior of the structure depends on those motions very much. Let's say add one ground motion. If to select the ground motion, you can just click in Y or X direction columns, or you can just use the buttons above the table. Open timestamp. When you select open timestamp data file, program will give you will let you to select your ground motions from any folder. But for now, I will just use the defaults. And let's see, when you select the open timestamp data file, as I said before, the dialog for selecting files is open. When you click preview data, you will get the raw file for ground motion. There is the delta t value and number of points and other informations. Those records are taken from peer strong motion database, and you have to enter your delta t dt values correctly, and by just previewing the dt values, the delta t values, you just enter them here correctly. And header lines to skip is those header lines. If we just write 99, for example, you can see those lines are skipped also. We have to select these two numbers correctly in order to select the time story correctly. Let's get on scaling procedures. Let's use 11 records for scaling, but as you know, the time story analysis can last really long. I will just use one record and analyze the structure by using it, but for scaling purposes, I will use 11 records. When you enter the ground motion scaling interface, there are some scaling parameters. For now, we are just using basic scaling procedures, basic scaling method. To give more information about basic scaling methods and also to other approach on basic scaling procedures are also can be selected. Let's just scale our ground motions and check our structure. Check our. Let's just use one, not use average. Let's see. Plot on the scale region. Those factors, the period of the structure, spectrum factor. Spectrum factor is used for where do you want to scale your ground motions. Ground motion scaling procedures. All ground motions are enter to new mark step-by-step integration procedure, and by using it, you will get the acceleration response spectra of the ground motions, and by using those acceleration response spectra, you will get this by using those strong motions, you will get acceleration response spectra, and average of the those response spectra will be above the elastic spectrum, scaled elastic spectrum with spectrum factor given here. Let's talk about upper bound and lower bound factors. Those factors are where do you want to scale which in which region we scale our ground motions. If you select those parameters, you will see directly the boundaries are changed. And let's see on just scaled regions and plot scaled spectra. As you see, when we select average as scaling method, just you can see here the dashed lines. First dashed line is our target spectrum. Second is our average scaled ground motions. Let's plot unscaled spectra or plot average. This is the unscaled average, and this green dashed line is scaled average. Sorry. And let's say we just check the scale factors. Since we scale by using the average, all scale factors of the ground motions are the same. If you do not want to use it like this, you can scale each by using each spectrum option. When you use each spectrum option, it will just scale each spectra, acceleration spectra by using target spectrum. And if you use it like this, your scale factors will be different, and it can be used like this. And let's remove those ones and scale one more time, and let's conduct a nonlinear time story analysis. I will say okay again. I want to use approximate reverse definitions for all those members who doesn't have any rebar definitions. In this stage of the nonlinear analysis, element force deformation relationships are prepared. Those force deformation relationships are, as I mentioned before, moment curvature relationships. And as you can see, you can track the progress of the nonlinear time story analysis by using OpenSea the interface. The step information will be given over there. As the analysis continues, I want to mention about more on our roadmap. First of all, we want to support other structural codes assessment procedures and also custom member performance levels, member plastic rotational limits, or custom performance goals implemented Prota Structure. and we will analysis post-processor for OpenSeas analysis, not only for now. We can obtain all results as plain text. We post-process them automatically to using assessment procedures, but in our new version, Prota Structure 2012, there will be analysis post-processor, and you can track the deformed shape of the structure, and you can track the plastic hinge occurrence at our post-processors. And for pushover analysis, the force vectors, reference force vectors, will be enlarged. For now, as I mentioned before, we using equivalent static earthquake force vectors, but model pushover analysis will be implemented also. And first mode, second mode, end mode, or combined mode analysis. We are planning to enlarge the scaling methods. For now, we are just using basic scaling, but another procedures will be implemented. They are on our plans. Sorry about long duration, but as you all know, non-linear time story analysis is last. The analysis duration of it is a little bit longer. After doing the non-linear time story analysis, I will check out detailed reports of time story analysis. You can select and see all time step results and average envelope results of all analysis. Assessment, we are using average envelope results of non-linear time story analysis. As you can see here, I want to mention about more on how we determine those two analysis. We give two run motion for two principal axes, and for scaling, we are just using combining them in and combining them in by combining them, and for each set, each one of the set, there will be two analyses conducted. Let's say this is 1 and 1x, and this is 1y. First analysis is the principal directions are 1x and 1y, and for other analysis, the second one just running right now is just switched. The directions of the ground motions are switched and repeated again. Prota structures. Prota structure gives you a lot of time to save your time by post-processing whole batch data. As you can see, the number of points in one motion files is 2,500. for each analysis with this output time step. By the way, you can change the output time steps by entering here. If you change this value from 0.02 to 0.04, the results are recorded by skipping by for those selected intervals, and for each member, for each end, I end and j end, for these time steps, all member responses, member dynamic responses are created in model directory. Let's just check those out files. Here in project folder, the opposite folder, the first analysis is done. Analytic model is created in here as TCL files, and here, as you can see, a lot of data is generated. We open this one with Notepad. You can see this is the raw data. By post-processing those amounts of raw data, we can prepare our detailed results. Our detailed results are represented as average envelope results, and you can select and see each specific time history, and also not only envelope results of each analysis. You can go and see each time step results, and those results are also shown in detailed reports. This one is average envelope results, and also you can get specific envelope results of the member for any time history analysis, or you can just simply click and specific time results. Let's say 100 time step. At that given time step, the report is prepared, and you can also check detailed results from those reports, and also report of the assessment report of the time history analysis. Let's check the time history, nonlinear time history analysis assessment report. Here the ground motions are presented, and scaling and also scale factors, and also same assessment values are presented in here. Thank you all for listening. This is all I want to talk about our assessment interface. There will be survey after the webinar. If you can kindly fill out that survey, it will be much appreciated. I hope it was beneficial for you. I hope you enjoyed our presentations, and I want to also thanks to Burak for his good presentation. If you have any questions, please drop them to our support center. And thank you all for joining our webinar. If you want to know if you want to know our latest webinars, if you want to be informed our latest webinars, you can follow our Instagram or LinkedIn profiles. Thank you.
Press the bell icon on the YouTube app and never miss another update.